Good afternoon to all of you. Today we are going to solve the problems on initial condition. This is question number 6. What I have given notes to you people. In the circuit shown in below figure A, switch S is closed at t is equal to 0. At t is equal to 0, switch is closed with zero inductor current and capacitor uncharged. So with zero current is not flowing through the inductor. At the same time, capacitor was completely uncharged. You are requested to find current I, di divided by dt, d square I divided by dt square at t is equal to 0 plus. So t is equal to 0, 0 inductor means t is equal to 0 minus, just before closing the switch, there is no current will be flows through the inductor as well as the capacitor is completely uncharged. Now solution for this, when switch S is closed, when switch S is closed, what is the equilibrium equation? Equilibrium equation to the above figure A, So what is the equilibrium equation for this figure? R into I plus L into di divided by dt plus 1 by C integral of 0 to t I into dt is equal to V. This is what the equation. This is, let us say, equation number 1. So t is equal to 0, there is no current flows through the inductor as well as the completely capacitor is uncharged. What is at t is equal to 0 plus? At t is equal to 0 plus, just after closing the switch, the inductor will be behaves as an open circuit. Initial conditions low, inductor will be behaves as a open circuit, capacitor will act as a short circuit. This is you know very well, and if you watch my previous videos you are going to get the information. So now at t is equal to 0 plus, so you are having the value of V and the switch is completely closed. And you are having a resistance. Inductor will be L will be act as a open circuit and capacitor will be act as a short circuit. Okay, so this is the current I of 0 plus. At the condition is t is equal to 0 plus. Therefore at t is equal to 0 plus, I of 0 plus is equal to 0 amperes. So I is completely 0. Next, you need to calculate di divided by dt. So from equation 1 to find di divided by dt, question mark from equation 1, what is equation 1? R into I plus L into di divided by dt plus 1 by C integral of 0 to t I into dt is equal to V. So just what we need to do, we need to find the value of di by dt at t is equal to 0 plus. Okay, t is equal to 0 plus. What we are going to do, we will be substitute r into I of 0 plus L into d by dt into I of 0 plus 1 by C integral of 0 to 0 plus 0 to, you need to be calculated at t is equal to 0 plus. So integration you should take 0 to 0 plus I of 0 plus into dt is equal to V. What is V? So what is the value of R? He is given the value of R is 10 ohm. 10 multiply with what is I of 0 plus? I of 0 plus condition of I of 0 plus is 0 amperes. So you need to substitute here 0 plus. What is the L value? 1 multiply with, you need to be calculate this parameter di of 0 plus divided by dt. If you substitute the integration, if you substitute the limits, okay, 0 and 0 plus, complete this term will be, you are going to get 0. So what is the value of V? V value will be 100 volts. So you need to write it as 100 volts. Now di of 0 plus divided by dt is equal to 100. So this is equation number, this is ampere per second. This is how you need to be calculate d by dt into I of 0 plus is equal to 100 ampere per second. Now you need to be calculate d square I divided by dt square. So d square I divided by dt square. ఎలా calculate చేయాలో ఒకసారి చూడండి. So how to find d square I divided by dt square? To find d square I divided by dt square. So question mark. Okay. So first of all, equation 1. Observe the equation 1. So equation 1 we need to be differentiate. This is the equation number 1. You need to be differentiate equation 1. Differentiate equation 1 with respect to t. Okay, so you are going to get r into di divided by dt plus l into d square I divided by dt square plus I by c is equal to 0. Just you need to be substitute at t is equal to 0 plus. So what you are going to get, r into di of 0 plus divided by dt plus l into d square I of 0 plus divided by dt square plus I of 0 plus divided by c is equal to 0. Okay, the value of r will be 10. The value of di of 0 plus divided by dt is 100. So you need to substitute 100 plus the value of l is 1. Multiply with the parameter. What you need to be find is d square I of 0 plus divided by dt square. What is I of 0 plus? I of 0 plus will be 0. 0 by 6 is 0. So what the value you are going to get? D square I divided by dt square into 0 plus is you are going to get minus 1000 ampere per second square. So this is how you need to be solve the problem. Okay, when you are substituting the limits, see here at t is equal to 0 plus. So in place of t you need to be substitute the 0 plus. So when you are substituting the limits 0 and 0, this completely 0. Here you need to be very careful. So the value of 10 I of 0 plus will be 0. 1 into di divided by dt of 0 plus is equal to 100 ampere per second. If you want to find the d square I divided by dt square, differentiate the equation 1 with respect to the t. You are going to get this equation. If you substitute the value of t is equal to 0 plus, okay, ultimately you are going to do, after doing the simple simplification, you are going to get minus 1000 ampere per second square. So this is the question number 5. The question number 6. Now question number 7. You see in your notebook the question number 7. In the question number 7, he is given the value of R will be the 10 ohm, the value of L will be the 1 ohm, and the value of capacitance is given 1 microfarad. This is question number 7 in your notebook. Okay, 1 microfarad. Okay, the value of voltage V will be the 10 volts. Now the value of voltage will be 10 volts. Same question, he did not change anything. In the examination he is given in the circuit shown in below figure A, when switch S is closed at t is equal to 0 with 0 inductor current and capacitor is uncharged, find the value of I and di by dt and d square I divided by dt square at t is equal to 0 plus. This is what the figure is given. First step, t is equal to 0 inductor current and capacitor is completely uncharged. Okay, capacitor is completely uncharged. But thing is, t is equal to 0 minus, there is no current will be flows through there was no current at t is equal to 0 minus, there was no current is flowing through the inductors and capacitor. Therefore, I of 0 minus is equal to 0 amperes. Now what you need to do, when switch is closed, when switch S is closed, the equilibrium equation, how you are going to get? No, the equilibrium equation is given by, okay, so you are going to get R into I plus L into di divided by dt plus 1 by c integral of 0 to t into I into dt is equal to v. Okay, so when switch is closed at t is equal to 0 plus, when switch is closed at t is equal to 0 plus, when switch has been closed at t is equal to 0 plus, what you are going to get, this is the value of v. Okay, it was closed, switch has been closed, the resistance will be remain same, R will be remain same, inductor L will be act as a open circuit, and capacitor will be act as a short circuit. Therefore, I of 0 plus, since it is an open circuit, I of 0 plus is 0 amperes. When t is equal to 0 plus, I of 0 plus is 0 ampere. Now you need to be find out di by dt. See, differentiate the equation 1 from equation 1. Ri plus L into di by dt plus 1 by c integral of 0 to t into I into dt. T is equal to 0 plus. when just substitute r into I of 0 plus L into di divided by dt of 0 plus 1 by c integral of I of 0 plus into dt, where the limit will be 0 to 0 plus. What is the value of r? R value will be 10. R value will be 10 into I of 0 plus is 0, since you are going to get 0. L value will be 1 into d square I of 0 plus divided by, I mean to say di divided by di divided by dt into 0 plus is equal to, if you apply the limits will be 0 and 0, you are going to get the 0 value. The value of V will be 10 volts. The value of V will be 10 volts. Therefore, you are going to get 10 ampere per second. You are going to get 10 ampere per second. Now, you need to be calculate d square I divided by dt square. So, to find d square I of 0 plus, you need to be calculated dt square. Okay, d square I divided by dt square, where at t is equal to 0 plus. So at t is equal to 0 plus, you need to be calculated. So differentiate the equation 1. Differentiate equation 1. Differentiate equation 1 with respect to the time t. You are going to get r into di divided by dt plus L into d square I divided by dt square plus I by c is equal to 0. I by c is equal to 0. So at t is equal to 0 plus, r into d I of 0 plus divided by dt plus L into d square I of 0 plus divided by dt square plus I of 0 plus divided by c is equal to 0. Now what is r? R value will be 10, multiply with what is the value of di divided by dt of 0 plus? You have got 10 amperes plus the value of L is 1. You need to be calculated the value of d square I 0 plus divided by dt square plus what is I of 0 plus? 0 divided by c is equal to 0. You are going to get d square I of 0 plus divided by dt square is equal to minus 100 ampere per second square. So this is how you need to be calculated. Only thing is you need to be get the equation perfectly. Ri plus L into di by dt. You can able to write this equation like this also. L into di of dt divided by dt plus 1 by c integral of I of t into dt into 0 to time period t. So that if you substitute the value of t here, I have substituted no, t is equal to 0 plus. If you substitute, you are going to get the same here. Okay, after doing the simple simplification, you are going to get this value. After doing the differentiating the equation 1, you are going to get this equation. Okay, I hope you understand the concept. Thank you very much for watching this video.